Hi, so today in class we'll be studying the average rate of change and the instantaneous rate of change. You most likely already know that the difference between the two, but just to clarify, when you are finding the average rate of change of a function, you are finding the slope of the second line between the 2 points. While when you are finding the instantaneous rate of change, you are finding the rate of change at a particular moment. Same as the value of the derivative at a particular point. For a function, the instantaneous rate of change at a point is the same as the slope of the tangent line, that is, its slope of a curve. So, to find the average rate of change from point TA to TA plus h, you can use the difference quotient and the position function. As you can see right there, I wrote down the difference quotient for you. For the first example, we are given the function negative x cubed plus 4x minus 2, and we are trying to find its average rate of change between x equals 5 and x equals 7, as you can see right there. In order to do this, we must first look at the first point, x equals 5, and how far away it is, so we can do the difference quotient. So I'm going to begin by writing down x equals 5 on the left side, then the difference between the 2 points x equals 2, and for the piece where I need x plus h in my difference quotient, I'm simply going to add the 2 together and use 7, as you can see right there. Then I'm going to write down the difference quotient and start plugging in all the different points into the function. So, as you can see, for x plus h I plugged in 7, for x I plug in 5, and for h I plug in 2. Then, after doing the necessary calculations, you end up eventually having minus 317 plus 107, and you evaluate this over 2, resulting in the average rate of change of negative 105. So, for the second example, we're basically do the same thing as we did in the first example, but with a much larger number. We're given the function 200 plus 60x minus 2x squared plus x cubed. We're trying to find its average rate of change between x equals 2000 and x equals 2186, as you can see right there. And in order to find it, we need to do the same thing we did in the first problem. And we first look at the first point, which is x equals 2000, and how far away it is, so we can do the difference quotient. So we write down x equals 2000 on the left side, as you can see right there. Then the difference between the 2 points, h equals 186. For the piece where I need x plus h in my difference quotient, we add the 2 together and use 2186. Then we write down the difference quotient and start plugging in all the different points into the function. As you can see, I plugged in for x plus h, I plug in 2186. For x, I plug in 2000, and for h, I plug in 186. Next, we go to the next page. After doing the necessary calculations, you end up eventually having 1.04 to the exponent of 10. Minus 7.99 to the exponent of 9, and when you evaluate this over 186, it results in the average rate of change of 1.23 to the exponent of 7. So to finish the lesson off, we're going to try and look at the instantaneous rate of change. For the first example, we are given a simple function of x squared plus 3. We're trying to find the instantaneous rate of change at 6. In order to do this, we must first look at the first point, x equals 6, and create a second point very close to it, so we can do the difference quotient. So I'm going to begin by writing down x equals h on the left side, as you can see. H equals 0.001. And for the piece where I need x plus h, my difference quotient, I'm going to add the 2 together in like the previous examples and use 6.001. Then I'm going to write down the difference quotient and start plugging in all the different points into the function. As you can see, I plugged in 6.001, 6, and 0.001 for h. After doing the necessary calculations, you eventually end up having 39.012 minus 39 all over 0.01. And this results in the instantaneous rate of change of 12. But there's another way of finding instantaneous rate of change, and it's by using derivatives. So to begin with, for this example, we're given the function 1000x minus 5x squared, and we're trying to find its instantaneous rate of change at 500. So we begin by stating the limit of the function at h, as h approaches 0, and writing down the difference quotient. On the next line, we continue to write the limit and plug it in the function, which results in 1000 bracket x plus h close bracket minus 5 open bracket x plus h close bracket squared, and subtracting the original function open bracket 1000x minus 5x squared close bracket all over h. Next, we begin to simplify the function by first writing down the limit, which is still h approaching 0. The function then is 1000x plus 1000h minus 5x squared minus 10 times h squared minus 1000x plus 5x squared all over h. We then cancel out 1000x with the negative 1000x and minus 5x squared with the positive 5x squared. On the next line, we still keep writing the limit, and here we factor out h, which results in the function h open bracket 1000 minus 10x minus 5h close bracket over h. We then cancel out the h's and plug in the limit for h, which eliminates the negative h, negative 5h, which finally gives the derivative of 1000 minus 10x. We then make the function equal 500. We minus 1000 from 500 and divide it by negative 10. And we find x, which is the instantaneous rate of change at 500. Thank you. And just to make the writing more clear, I'm just going to take a video of both of the sides just for you to see. Thank you for listening, and this has been Ivan with instantaneous rate of change and average rate of change.